conscious about today. So we're looking at what we call parts of similar triangles. Remember, similar means they're the same shape, but they are different sizes. They are not congruent. You might have a small triangle, a big triangle, that sort of thing. So again, nothing for you to write down. This is on your paper. I'm just going to read it to you. If two triangles are similar, then the corresponding parts, same keyword as always, proportional. So we're going to have the fractions. We're going to be using the cross products, all the good stuff. So there's three, like I said, three specific cases, three specific vocab words you got to be aware of. One of them, altitude. Now, altitude, of course, there's nothing for you to write down yet. I'm going to write on the side for you there in a minute. So this is the first one, the altitude. Altitude, just so you know what it is the height of the triangle. Now, here's the thing. Altitude and height are synonymous. So the altitude always makes a right angle. So this is an altitude, this is an altitude. So when you go to do your proportion, this is what you guys have to fill in on the side. You're going to start with the altitudes. So I'm going to do BD over FH. So you have to fill this in. Over there on the side of your notes. Now, here's the thing. It depends on what side they give you. Okay, they could give you the left sides. So you could have BA over FE. They might even, and I'm not going to get carried away and put all the different possibilities, but they could give you these right sides also. The key is you have to start with the altitudes, the segments that make the right angles. So that's the first thing I'm going to be looking for on the right angles are the altitudes. Then it's a matter of if they give you the green sides or the purple sides. They're not going to give you both green and purple. You're going to have one or the other. Now, the second case, we know this phrase, angle bisector. Of course, it cuts the angle in half. So you're going to fill in the proportion again. Now, same thing. First thing I'm going to look for is this angle bisector. So QS and UW. So I'm going to start with that. Okay. From there, it's kind of like the last one. It just depends on what they give you for sides. They might give you these left sides. So I'm going to put QP over, of course, UT. Now, they might, again, it just depends on the problem. They might give you the right sides. So the green you would swap in place for the blue. It just depends on what they're going to give you. They're not going to give you both. But you always start with what I like to call the special segment. So I'm always looking for either an altitude, the red here, the angle bisector. Here's a new one for you, a median. Let's scroll this up. So median is a segment from the vertex of the triangle to the midpoint. That's such great vocabulary. Midpoint, right in the middle. So the median cuts it in half. But same thing, I'm still looking for the special segment. This is my median because it's cutting the side in half. Same on this guy. So I'm going to start with those. HJ over LN. And then from there, it just depends on what they give you. They might give you the right sides, or they might give you the left sides. Just to mix it up, I'm going to put the right sides down this time. So HI over LM. Or again, they might give you the green sides and you would swap those out in place of the blue. Okay, it just depends what they give you. But let's just summarize this. I don't want you to be like, oh my gosh, is it a median, an altitude, an angle bisector? What is it? Just notice what's the commonality. All of these special segments are in the middle, all the reds are in the middle of the triangle. So you're starting with those today. Now, of course, you know I love vocab, so I'm going to talk about the vocab here. All right, given the similar triangles, of course, go through and solve for x. So first thing I'm taking a look at. So here, of course, just, vocab, this is a median because you have these congruent sides. So I'm starting with the side in the middle. So I'm starting with my special segments. So my first fraction, I'm going to do x over 15. And now it's just a matter here of how you want to do your sides, okay? But we have to be a little bit careful because I see like we have that one triangle is kind of rotated from the other one. So don't forget you always can use your similarity statement. Now, I'd rather use a whole number than a decimal. That's just how I'm going to roll. So I'm going to do the 16. But what side does 16 match up to on the other one? If you're like, oh my gosh, I'm not sure, look at your statement. We did ST. So that's going to correspond to DE. I can always use my similarity statement if I'm not sure. DE. All right, I know you guys are great. Solve that. You're good at your cross products. You get a nice whole answer. Got it. Bless you. Now, of course, you could have used the other side. You could have used 19.2 on the right and 24. You get the exact same answer, your choice. But we start with the middle. So same thing here. This time we have altitudes, right angles. So I'm going to start with the middle. So I'm going to do 10 over 8. Now, this one to me is pretty straightforward because what are the only other sides you have on the triangles labeled? What has to be your next fraction? What over what? Don't all yell it at once. X over. Got it. All right, solve it. You don't have any other choices for this one. You do get a decimal for this one. Just you got it, 17.5. All right, let's take a look at the third one. So again, just the love of math and vocab. Here we have our angle bisectors, cutting this angle in half, but we know we start with our middle segment. So 32 over 24. And then what is going to be your second fraction? Yep, you got it. Like robots in here, perfect. I'll give you a sec. You get another decimal. As you can see, we get a lot of decimals in this stuff. Got it. All right, we got a little twist on the next one. Any questions on those so far? Okay, next one. I know I've been preaching about starting in the middle, but I'm like, ooh, wait a minute. They gave you some fancy pictures here. I see the right angles. You do have altitudes on these. But this time, just because our triangles are obtuse triangles, some vocab, bigger than 90-degree angles of obtuse here, your altitudes are on the outside. I'm still starting with the altitude. So I'm still starting with the right angle. So I'm still going to do 15 over 12 or 12 over 15, however you want to do it. Since I did 15 over 12, what has to be your next fraction? Perfect. So that's one of the big exciting tricks is the altitudes are on the outside on your obtuse triangle. Not that that's a big deal. Another decimal, my friends. Got it. So any questions on the front side? Okay, back side. Man, this is a good one. I'm psyched for this one. All right, let's take a look. All right, quiet and listening. Quiet and listening. Here we go. All right, for this one. Listening. So this one, of course, we have a median again. Just, I like to use the vocab, not that you have to get carried away with it. Median because you have the congruent side. So I'm starting with the 20 over here, and I'm starting with the x minus 5. Okay, what is your second fraction then? Is it 15 over 2x minus 9 or 2x minus 9 over 15? Okay. Now, let's do the work on this one. This is a fun one. So we're going to do our cross products. This part's easy. 20 times 15, I'm not even worried about. Punch that in your calculator. It's 20 times 15. The other diagonal I'm a little worried about because we're going to have to multiply or FOIL these two binomials together. So a lot of algebra review. We love to review our algebra in here, so let's do this together. So let's start distributing. X and 2x. Or for those that like FOIL, I just did the first ones. Now I'm on the outer. X and negative 9. Inner. Negative 5 and 2x. Negative 5 times negative 9. What's 5 times 9? 45. Okay, how many answers are we going to have to this? 2 because of the squared. We're going to have to factor. It's all the good algebra stuff. I'm going to set it to 0. Let's subtract the 300 over. We're going to have some big numbers, which I don't know if I love that, but it is what it is. So 2x squared. Let's combine our x's. What's negative 9 minus 10? Negative 19. Got it. You might need your calculator for that. What's 45 minus 300?
Negative 255.
Okay, I'm going to scroll this up a little bit because I feel like I'm at the bottom, and we've got some work to do. I would do this on my calculator all day long because to factor this, you have big numbers, big. First, you have to multiply 2 times negative 255. Somebody punch that in. 510, is that it? Now, you have to figure out what multiplies to that and adds to negative 19. I don't know about you, but I don't know that off the top of my head. I'm going to go to my calculator. So I'm going to put in y equals, I'm going to change this to negative 510 divided by x. And hit second graph to pull up the table. So now I'm looking through this for a combination of numbers that add to negative 19. I have a feeling I got to scroll more. What do you think about 15 and negative 34? What's 15 minus 34? Somebody punch it in.
Negative 19.
Isn't that what I'm looking for? Add to negative 19. So I'm going to use 15 and negative 34. That adds to negative 19. So let me write those down. 15, negative 34. Now, those aren't just going to be your factors. We're still going. This is the never-ending problem. This is good algebra review. You have to remember you have to divide them both by what? 2. Now, 15 over 2, of course, that's not a nice number. I'm just going to put that in factor form, the bottom first, then the top. And hopefully we can do 34 over 2. What's 34 over 2?
Negative 17.
That's easy, right? So now we can get our 2 answers for x. Ooh, this is a good one. So to solve this for x, you'd have to subtract 15 and divide by 2. To solve this for x, what are you going to get? And obviously, which answer am I going to use? Because if you plug that in, you're going to have a negative length of a side, which we know we cannot have it here. Ooh, that was fun because of the factoring. Are they all that bad? No, but of course we always like to review the algebra in here. Any questions on that? The geometry was easy, setting up the proportion. The factoring there got a little spicy for us. All right, these are easy but tricky. I'm going to preface it with that. So last thing I have to show you for this chapter. Here we go. Quiet and listening. Quiet and listening. So angle bisector in a triangle separates the opposite sides into 2 segments that are proportional, man, this is a mouthful, to the lengths of the other 2 sides. So angle bisector, of course you have those 2 congruent angles. So first off, you're looking at the opposite sides. So my first fraction is, I'm going to put AD over DC. You're looking at the opposite sides of those congruent angles. AD over DC. So start with that. Now, from there, because they're not going to give you BD this time, you have this one combo picture. You're also going to know the outsides. So I'm going to do BA over BC. So here's kind of how I remember this one. This is one very specific, unique little case that pops up. I remember it as I always think about opposite sides first. That's the purple fraction. And then I just think of the other sides. So I'm always looking for those opposite sides first from the angles, from the congruent angles. When I say opposite, directly across the congruent angles. So let's try this. This is one unique case. So again, blah, blah, blah. It's an angle bisector. So of course these are congruent. They just didn't mark it. So again, I'm going to start with the opposite side. So I'm going to start with the 4.8 and the x. And it doesn't matter if you do x first, 4.8 first, doesn't matter. I'm going to do 4.8. Now, keep it matched up though for your opposite side. Since I started with 4.8, is it going to be 18 over 12 or 12 over 18? 12 over 18. We're going to stay on that little triangle over the other. So this is still easy, but it's one very specific case where you just have to straight memorize. It's the opposite pieces over the other sides. All right, you solved it. What do you got? Perfect. And again, we can see we're getting a lot of decimal answers. So same thing. It says KM is that angle bisector. So they just didn't mark them, but there's your congruent angles. So I'm starting with the opposite sides. So 36 and 40. And it doesn't matter if you go 40 over 36, 36 over 40, who cares? I'm going to go 36 over 40. Now set it up for me. Opposite sides. 54 over x or x over 54? X over 54. I got to stay on this left triangle. And I know you're going to be shocked when I say this. You get another decimal answer.
48.6.
Got it. All right, final couple ones of these. Same thing, it says it's the angle bisector. I'm going to put these on. All right, we got to do some mental math here. We need those opposite sides. Clearly the one is 15. What's the other one? Let's see, because you have to add to 39, right? Okay, and then of course our opposite sides. We're going to give you 50-50. Is it 36 over x or x over 36? Good, I heard it. X over 36 since I started with 15. I'll let you solve it. And shocker, we get another decimal.
22.5.
All right, any questions on that? Ooh, I got a good one for you, this next one. Okay, so same thing. We've got our angle bisector, just like it said in the directions. So we're going to do our opposite sides. Now, the first opposite side is obvious, clear as day, 12. This one is the dicey part. Get ready for this. We got to use some algebra. If this was a number, this x would be super easy. Like if that was 20, you could just do that with no work. You tell me this is what?
8.
Because how did you get it, Tusky? Did you add, subtract, multiply, divide?
12 minus, or 20 minus
You
12.
subtract. You subtract. I'm looking for the minus. He subtracted. So here we go. To get this side, you have to take the entire length and subtract off the 12. So this is the other tricky part of today is you have an algebraic expression for that. So that's my other opposite side. Okay, 18 over 30, 30 over 18. Got it. Now, of course, we have a little more work on this one because of your x minus 2. You're going to have to distribute. Don't forget, too, you could reduce 18 over 30 if you don't want to work with such big numbers, but I think we can do it. What's 12 times 30?
368.
Okay, we're going to distribute 18 through here. 18 all the way through x minus 12. And I know some of you can skip what I just wrote and go right to this line, which is fine. What's 18 times negative 12? Negative 2 what?
216.
Perfect. Okay, finish solving that one. This is the only one on this page I think that comes out nice.
X equals 72.
What do you have for it?
Isn't 32?
You should get 32.
Yeah.
Add your 216. So take a look at this one more time before we do the final one. Focus, people. Is there any explanation or any help I can give on how I got the x minus 12? I took the whole thing and I just subtracted off the 12. That's the only tricky part of this. All right, last one. Of course, you've got your angle bisector still. Says KM's the bisector. So here we go. Opposite sides. I'm going to start with the easy one, 27. What's this missing piece? This you can do, well, you might need your calculator, but this one's easy. 18 because they have to total to 45. And then your other sides, of course. 3x minus 9, x plus 11. Now, still easy, but you're going to have a lot of distributing to do on this one. So you're going to have to do 18 times 3x minus 9. Definitely need your calculators there. And then 27 through x plus 11. I'm going to give you a minute to solve it and see if you can come up with a final answer. You get a nice whole number. See what you get. You get a nice whole number answer. See what we get. I think Tusky's just guessing over here. What's Andrew got?
17.
See, do we agree with Andrew? He's got 17.
You're wrong.
Can't believe I'm going to say it. I agree with Andrew. You should get 17, everybody. Good work, Andrew. Husky's just making up numbers. Okay, any questions on how to get the 17? I'm happy to do the work, but I don't want to bore you.
No.
All right, that is